me. My name is Schroeder. I'm a senior here at Wayne State, and I'm from Ravenna, Nebraska. I'm an interdisciplinary studies major who's focusing in biomechanics and applied engineering. So the goal of this project was to kind of incorporate some of the different interests that I have and be able to put that into something that I can use from here at Wayne State. So our project was to investigate the kinematic differences between overground and treadmill running in collegiate runners, and we thought this would be a fun project to do because we have access to facilities to do it, and it's just an area of interest of mine as I am on the track and cross country team, so it's something I'm really interested in. So to start off, cross country athletes, they don't often utilize, or they do often utilize overground and treadmill runs as a part of their training program and regimen. So as an athlete, I personally do utilize the treadmill. I have some teammates who are against using the treadmill. They'd rather not because whether it's just personal preference or something that maybe they don't like running on the treadmill because of how it feels, or if it's just a mental thing where they just don't like the monotony of it. So that's something that's often utilized in training, and running kinematics do significantly influence running economy, and these can be impacted from treadmill and overground running in different ways. So the studies that I researched initially only used one surface type, so they only investigated it on the treadmill or on overground running. And another thing that they did is they only analyzed biomechanical characteristics as opposed to actually comparing the two surfaces. So published research that are observing the modalities, so treadmill running and overground running, these effects aren't as published in research, and it's very limited. So the goal was to observe and compare kinematic characteristics of running overground versus on the treadmill in collegiate distance running athletes. So I just wanted to talk to you guys a little bit about some of the articles that I reviewed and was able to get a little bit of insider information on to how running kinematics and form impact running economy and the importance of these factors in running. So the first study that I investigated included 97 endurance athletes, so they had a decent population size, and they only used the treadmill for this study. And they used 4-minute incremental treadmill runs, and they investigated numerous kinematic variables. They investigated vertical oscillation, braking, posture, and lower limb angles. In my study, I did stride length, stride frequency, and vertical oscillation. So they matched some of the same kinematic variables that I did, however, they only did the treadmill. And they determined that running technique drastically influences running economy and performance. For the second one that I felt like was beneficial to talk to you guys about, they stated that runners with good running economy generally use less energy. I think this is kind of a common known fact in the community, that if you're more efficient while you're running with your biomechanics, you're able to perform better for longer. So in addition, they use less oxygen than inexperienced runners. And muscular ability to store and release elastic energy also affects running economy. This is also directly related to biomechanics. And some of the factors, the biomechanical factors that are included in this, are vertical oscillation and muscle stiffness. And ultimately, they determined that biomechanical factors can affect running economy, and it's a key successful aspect to distance running if you can be biomechanically efficient. The final article I reviewed that I felt was essential to this study and was really relevant to this study was this one performed by Lindsay in 2014. It's called The Effect of Treadmill versus Overground Running on the Structure of Variability in Stride Time. So this is the one study that I found that did compare overground and treadmill running. However, they only investigated one of the kinematic variables that I also investigated in my study. For theirs, they analyzed gait timing dynamics of treadmill versus overground running, and they used 9 trained distance runners. They had a very small population size, similar to my study, and their subjects ran for 8 minutes at a self-selected pace. We also did this in my study where we had the athletes perform an easy run overground, and I'll elaborate a little bit about that here in a minute. But and treadmill running requires increased voluntary control. So throughout their study, they determined that overground running doesn't necessarily reflect the same biomechanical dynamics of running as on the treadmill. So this is something that we had to keep in mind while we were going through the results of our study. To participate in my study, they had to be members of the Wayne State cross-country men's or women's teams. We did this because we wanted the population of our athletes to be very similar in a lot of aspects. So if we had an athlete who wasn't a member of the team, there might have been some outliers in the results. So having a really cohesive group of individuals participate in the study who demonstrate a lot of the same running characteristics would help maintain the integrity of the results. And then they had to be cleared by the athletic training room for full cross-country participation. So we conducted this study in early to late November, and even, I think, into early December. And this was post-cross-country season, so all of our athletes had been participating in cross-country, had been injury-free for at least a month because they were supposed to be fully participating in practices. So being able to confidently participate in practice and meets allowed us to ensure that they were going to be injury-free and in good shape so that they wouldn't be fatigued from our running and that they wouldn't pose a risk for injury. And then also we had them provide informed consent, fill out a health history questionnaire, and then they had to be between ages 19 and 20 to 25. And one of our athletes actually turned 26 today, so he just missed that window. So a little bit of data about the participants of our study. We had 7 total participants, similar to the study conducted by Lindsay in 2014. And we had 3 males and 4 females who participated. The age ranged from what I said, 19 to 25. And below are the means and standard deviations for all of the different anthropometric characteristics, which I'll talk about again in a little bit. And at the bottom there, I have the paces that we ran, or that the athletes ran. It was really interesting to see kind of the difference in the self-selected easy pace of the athletes. We had some athletes whose personal bests in the 5K were roughly 21 minutes, so their easy paces were around 8 minutes per mile. And then we also had some athletes who were as fast as 14:40s for their 5K PR, so their easy self-selected pace was more like 6:20, 6:30 per mile. So we saw quite the range there, especially since we had male and female participants participating in the study. So now I just have an overview of the testing sessions that we conducted. The first was an anthropometric measurement assessment session, and that consisted of a couple different factors. And then the second session was a 1-mile run on the track, followed by a 1-mile treadmill run. And the third session was identical to session 2, however, we flipped the run order. So we had the treadmill run first, and then we had the track run second. In the study, we utilized a lot of different technologies. First, stadiometer, just to measure height. We have this down in the Human Performance Lab, and we measured height in centimeters. The digital scale, also to measure body weight in kilograms. This one I had never used before. It was a really interesting piece of technology that I didn't know existed, for that matter. But it's called an Omron body fat analyzer, and it uses light electrical pulses to calculate how much body fat you have, or what your body fat percentage is. So we use that to calculate body fat percentage. And then in the bottom right, that's a Garmin Forerunner 255 GPS watch. It's my current watch that I use right now, but after we did some looking into it, the Garmin Forerunner series is pretty reliable, and it's a pretty renowned watch in the running community. So we use that to keep track of stride length, stride frequency, and vertical oscillation. And then we also utilize the treadmill in the Human Performance Lab for the treadmill run sessions. So those are the technologies we used during the anthropometric measurement session. And for session 2, we actually ended up combining session 1 and session 2 in a lot of the instances because it worked better with their schedules, and the anthropometric session doesn't really cause or induce any sort of fatigue or have any effect in their running, so it just worked better in their schedules to do it that way. But for session number 2, we started with a 5-minute warm-up run. What I did for my athletes during the 5-minute warm-up is I allowed them to do whatever they felt was necessary for them to warm up, or what they would normally do before they were to participate in practices or races or whatnot. So that could be a 5-minute easy jog, that could be dynamic stretching, static stretching, whatever they normally do to get themselves ready to compete or run. And then following that, we did the self-selected 1,600 meter run on outdoor track. In this part of the study, I allowed them to kind of have free reign over the paces they chose. I just encouraged that it would be an easy pace that they'd be able to maintain over the course of the mile and on the treadmill following that first run. And then following that run, after tracking it with the watch, we walked to the Human Performance Lab. This was their recovery. It's a pretty easy self-selected pace, so recovery, although it may not seem necessary, it still might be important, especially when trying to separate those 2 runs. And then after we walked down to the Human Performance Lab, we did the second run on the treadmill, and we did the same pace. In order to do this, I found a treadmill conversion chart, which just converts your minute per mile pace to miles per hour, which most treadmills are calibrated to miles per hour. So we did that, and then following that run, they did a 5-minute cool down of their choice, whether that was walking laps around the basement of Rice, walking back to their dorm or apartment, static stretching, dynamic stretching, whatever they felt like they needed or normally do for normal runs. And like I said, the same methods were used for session 3. However, the treadmill run was first and the outdoor track run was second. And the only difference, or the only other difference between the second session and the third session was that we had them run the same pace as they did for the prior session. This was just to maintain consistency throughout the course of the experiment. And a lot of the athletes felt it was difficult to maintain that pace. Not difficult physiologically to maintain the pace, but difficult just trying to find that pace on the outdoor track because it's not set up for them with like a motorized treadmill, for example. So to collect data, like I said, we use the Garmin watch, and there's a software with Garmin called Garmin Connect, and you're able to pick apart a lot of different data points from that, especially on the online software. That's what I use to put the data points into Excel and to find all of the data I needed to statistically analyze it. And through Garmin Connect, we collected the kinematic data on 2 different points, or 2 of the same points for the different surfaces. So for the outdoor track, we took the segment of data for the last 80 meters of the track, so the final home stretch for the most part. And then for the treadmill, we used the last 5/100ths of each quarter of the run. For statistical analysis, participant description data presented as means and standard deviations of the group. So we, for the kinematic data, for the stride length, stride frequency, and vertical oscillation, we averaged it out for each run and found the standard deviation for both. And then student t-tests were used to identify differences between runs on each surface for each day. So for the results, for stride length, there were no significant differences between overground and treadmill running. However, we did see differences between treadmill runs on both days. So on the graph, so this is the treadmill run for day 1. And then on day 2, it was statistically significantly less. We aren't quite sure why this happened. We have some theories behind this, which I'll get into a little bit later. And then there were no noted differences between the track runs and the treadmill runs. The same was observed for stride frequency for the comparison between track and treadmill runs. There were no significant differences between the 2. However, there were significant differences between track 1 and track 2, where they averaged more steps per minute on the second day. My guess behind this is because it was more hard for them to find the pace, so maybe there was more variation in them speeding up and slowing down to try and find that pace while running on the outdoor track that they were trying to maintain. And then for vertical oscillation, there were no significant differences also between the track and treadmill runs. So across the 3 different kinematic variables we observed, there were no differences. However, in this case, much like the previous examples, there were differences between both track runs and both treadmill runs, but not when comparing track to treadmill runs. So for stride length, there was no significant difference, like I talked about, when comparing track and treadmill runs, but this contradicts the study that I talked about earlier, because they found that a decrease in stride length was apparent when running on track versus treadmill running. And in this study, they determined that the treadmill brings about greater dynamic constraints, which led to significant differences between stride length in track and treadmill runs, which was not observed in our study. For stride frequency, like I said before, there were no noticeable differences between track and treadmill runs, and this also contradicts the same study because they found an increase in stride timing existed on the treadmill because more coordination and focus is put on trying to maintain the pace on the treadmill, trying to not drift from side to side on the treadmill, not trying to fall off the treadmill. So that was something we observed there. And then vertical oscillation also didn't have any differences between track and treadmill running, like I had mentioned. And this contradicts the study also, as they determined that treadmill running is much more controlled and regulated than overground running, because there's a lot more variables that are to be taken into account while running outside. In addition, they observed that there were limited degrees of freedom on the treadmill. There were more limited degrees of freedom, which prevents excess movements while running on the treadmill, as opposed to overground running. So in our study, a lack of consistency was observed between days on the same surface, as opposed to between track and treadmill running. Contradictory to our study, Lindsay observed differences in kinematic variables between track running and treadmill running. And when comparing runs on the same surface, he observed very similar kinematics between treadmill runs. However, a difference was observed in track runs, and this is similar to our study. We did observe this difference between solely track runs. And for our study, there were a lot of limitations that we were able to come up with. The small number of participants is an obvious one. I think just the population size we had here of people who actively run every day consistently and are injury-free is very limited in Wayne. So obviously having a larger population size may have smoothed out our data a little bit, maybe given us a little more insight into trends that exist when comparing the 2 surfaces. Also, running over ground for our use of technology, it was more beneficial to do it outside. However, during this time of the year, with variations in weather, wind, temperature, we did experience some inconsistencies there. So if we were able to recreate this study, ideally we would have done it inside. But the Garmin watch, using it outside to track all of the variables, just seemed more realistic. But when we were using wind, or when we were dealing with the wind and dealing with the temperature, for example, I had athletes who were running on the home stretch, and for their first trial, they were running into the wind, and the second trial, they were running with the wind. So maybe that could have impacted some of the kinematic aspects of the runs. And then also the technology we used was another factor that we kind of ran into some small issues with. When running on the treadmill with the Garmin watch, you can calibrate it to the treadmill. However, I feel like there's still some inconsistencies there with measuring stride length and measuring stride or vertical oscillation, because if they don't have the accurate distance for the treadmill, there might be some variations that exist there. And then finally, using one self-selected pace, I feel like if we would have been able to investigate different paces, like running at your race pace, running at a really slow pace, we might have seen some differences between the 2 surfaces that we didn't. So for the end of the study, we concluded that significant differences were not present in stride length, stride frequency, and vertical oscillation when running overground versus on the treadmill. And obviously, this is just based on what we determined. It's not a said fact, like it's not said and done, because we still have all the limitations that I discussed to consider when considering this fact. Also, further research needs to be examined to determine the kinematic consistency of runners. This is something that I really do think is important when examining this as well. And then further research needs to examine running kinematics at various speeds. So being able to examine these runners at different speeds might also be beneficial in determining whether or not there are differences that exist between overground and treadmill running. And that is all I have. If you guys have any questions, feel free to ask.
What do you prefer? Do you prefer running on a treadmill, and do you think there's any biomechanical differences that you can tell from running a treadmill and outdoors?
Well, kind of like I was talking about earlier, like running on the treadmill, I do feel like I'm a lot more engaged in making sure, like I need to make sure I'm stepping in the right place. I think that's a little like contradictory though. I think some people think, it's maybe more dangerous to run over ground, but if you're engaged or not engaged on the treadmill, I feel like that's really dangerous. So personally, I like running outside if I can, but if I have to run on the treadmill, I will. Yeah.
I thought it was really interesting that the second set, because of the order, had a different trend. So even though it's not statistically significant, there was some trends that you saw.
Yes, and there was. Yeah.
And then you talked about the environments, if the wind and being outdoors, and that can certainly be explanatory to it. But did you, a couple questions on that. Did you have all the groups on one day and then all the groups on another day, so the conditions, the environmental conditions were the same for all of them?
So the way we did it is, ideally I would have done them one at a time, but we were running into like scheduling conflicts, and we were conducting this later in November, and I wanted to have this done in December. So the way we ended up doing it is, I think the biggest group I had was a group of 3, and I would just stagger them, like I had one do their overground run, and then they did their like recovery while the next person started their overground run, and so on and so forth. And I think the smallest group I had was 2. So some of them were done on the same days at roughly the same times, but then some of them had to go maybe in the afternoon or early in the morning.
So you can't probably make a conclusion that it was the weather they were running
Yes.
into the wind versus, yes. But it does raise a good question. So I'm asking, did Lindsay do the both ones in different orders like you did?
I don't recall if he flipped them, but I do know he did multiple runs on both surfaces. I'm not sure if he flipped them or not.
So given those questions I'm asking, do you think that the second run is going to be affected by the first run? Regardless of how it's done.
I see what you're saying. So like if I ran the track and then the treadmill, or the treadmill and the track, does the first run impact the second run? I don't think in our case it did necessarily because of the intensity of the run, but I think if the study was to be conducted again and they were doing it at a race pace or at a harder effort, then it definitely would have impacted it, or it would have been more noticeable anyways. Yeah.
Very interesting. I really like that. And then the second question has to do with gender, because the mechanics are going to be different between males and females.
For sure.
And did you, I know you had, that would make this groups even smaller, but did you look at the data within the genders?
We were going to, but we ran out of time.
Okay.
Yeah. No, that is something that we did want to look into,
Yeah.
but we just didn't have the
It'd be
time
interesting
for
to
it.
see if they both respond similarly, or...
I mean, there possibly could have been some differences. I mean, when I was watching them run on the outdoor track, for example, like, I'm usually in the runs with these people. I don't usually watch people run. So it was really interesting watching them run because the guys who ran all had very similar running forms. But when the girls ran, I noticed that a lot of them had very personalized running forms. And I mean, maybe there could have been some difference there, but yeah.
I have a question.
Yeah.
So given that, from my understanding, track usually takes place on an even ground over a track surface, whereas cross country is usually over uneven terrain.
Okay.
was consideration given into whether or not the athletes were more comfortable on uneven terrain for the study, which might have impacted their stride length for most comfortable running term, versus those who were used to running on a flat surface?
So are you talking about like, since it was during cross-country season, like?
So, because you pulled from the team of track and cross-country,
Mhm.
and some athletes may have been better accustomed to
Running on it.
running
Flat surface.
over a flat surface versus running over an uneven
Mhm.
terrain in competition. They're differing in stride lengths based on their specialization of running
True.
competitions.
Yeah.
Would that was any consideration given into whether or not that impacted their strength, length, and?
Yeah. So when we pulled from the cross-country team, they all had to be athletes who were competing in distances greater than 800 meters. So all of them are also competing in cross-country at that time. So I think also in addition to like the health history questionnaire, the clearance from the athletic training room, I don't think any of them would have had any problems running on a flat surface as opposed to an uneven surface. But I think there's definitely preferences. I think people would definitely prefer to go run 5 miles around town on uneven surfaces as opposed to running 5 miles on a flat track, if that's what you're getting at. So I don't know if there was many, are you asking if there are differences there?
So I think I got confused. Part of the verbiage in your presentation was
Mhm.
track and cross-country team
Okay,
instead of just cross-country.
so they're all
athletes.
cross-country
Okay.
athletes, yes, but they're members of both track and cross-country teams. Because generally, if you're on the cross-country team, you're a part of the track team.
Okay.
It's just, yeah. Mm-hmm. Yeah.
So was all data collected on your Garmin watch?
Yes, and there's a user profile function on the watch that you can adjust the gender, adjust the wrist they're wearing it on, so that it's all consistent with that.
Does that include their height and everything too?
No, that was measured just in the human performance level.
In the profile of the watch?
Yes, I believe it's on there. Mm-hmm.
So is it, you just said you looked into how the watch is similar or is, has good validity on
Mhm.
collecting the data?
Yeah.
What was that compared to, like for Lindsay? What did he use?
They used accelerometers. They used accelerometers as opposed to like a wristwatch, and to calculate or to quantify like the vertical movement and horizontal movement. Yeah, they used accelerometers. I'm not sure where they attached them, but they used accelerometers for that as opposed to a watch. Yeah.
Have you looked into anything of the specifics of taking stride, sprint machine stride length into what is their length of their actual legs? Because everyone could have a little bit
Yes.
different, longer torso versus.
Yeah. So there was, when I was doing my literature review, I was going through some articles that also did talk about the significance in anthropometric characteristics that and how influential they are in running economy and like your biomechanics. And it is something that we were going to consider. We were going to possibly measure like true leg length and like a couple other characteristics. However, we felt like since we were comparing each runner's form or kinematics within themselves and not comparing them to other people, we didn't think it was really necessary to do those anthropometric measurements. Yeah.
The final question for me, there may be others, but when you do these analyses of their mechanics, I hope the whole point is what's the point? You know, how do we know, can we train people to be more efficient in their mechanics and therefore be a better runner or be more? So can your data, if it was, you know, if you expanded on that, how would you use that to, and at the college level, are you still working on mechanics, or are you just assuming they've achieved their mechanical efficiency at this point, and now we just work on their conditioning?
So that was kind of one of the reasons why we chose to do collegiate athletes is we looked at their running history and how long they've been competing. And I don't know if there's like a fair amount of time to say, oh yeah, they've been running long enough to have good form, or if they're fully developed in their form. I think that's something you fine tune over time, over years and years and years. Like But our athletes all, I think the minimum amount of time they've been running collegiately was 3 years. They were all upperclassmen, so I think using this information, we might be able to utilize it to help develop them further in their form and their stride frequency and all that kind of kinematic data, but I don't know how beneficial it would be because I feel like that's something that comes naturally over time with as you get faster, you're not going to be able to get significantly faster without those biomechanical changes. Like in order to be more efficient, you need to be more efficient biomechanically to be faster. Like there's no way around it.
That's the point.
Yeah.
Yeah, so most natural athletes have a feel.
Yeah,
And that's what they do, is they become
Mhm.
more efficient, I think.
yeah.
Another thing maybe would be looking at that and seeing, is there an association with increased risk for injury,
Mhm.
overuse injury, with certain kinematic trends?
True. Like maybe if they're
The too much
taking less
oscillation.
steps on the
maybe,
treadmill, or
yeah.
more vertical oscillation on the treadmill than overground, maybe they're experiencing greater ground reaction forces that could impact injury. Yeah, for sure.
So maybe another study, looking in your future, is looking at an athlete's history of injuries, chronic injuries, maybe
Mhm.
fasciitis or something, or whatever,
Mhm.
and then analyzing the mechanics versus those who haven't had a history of injuries, and seeing if there's a mechanical difference between the ones that are more prone to injuries than those who.
Yeah, that would be interesting to see again.
Very nicely done. Yeah.
Is there else?
Curious to hear your thoughts. So the first day when they ran, you let them pick their pace outside,
Yeah,
and the second day you forced them into that same pace.
yeah. And that's where I think the stride length or stride frequency variation came in with that. Yeah.
Say from a runner standpoint, how hard is that to be given a specific pace and fit into it?
I think it very much depends on the person because, for example, if we're doing a track workout and our coach wants us to run a 80-second 400 for our track workout, I'm one of those people that can go out there and run within 1 second of that, but I know people that they let me do that because if they tried to do the same thing, they would be 5 seconds, 6 seconds fast or slow or, yeah, kind of like that. So I think it very much depends on the person.
Or how much time they were concentrating on the watch.
True,
Trying to
like,
speed up and slow
looking at it
down
all the time,
and
yeah.
instead of actually just
Mhm.
running.
Double stepping.
Yeah, experience
Yeah.
definitely comes a long way with that. We'll have freshmen who come onto the team who, like what I just said, like if they're told they need to run this time, they're going to be way off, as opposed to a senior on the team who could run the same pace every single lap because it's just muscle memory and familiarity at that point.
So what is your next research project going to be?
I have no idea. No idea.
I think your research design next semester.
Yeah,
Let's see.
yeah,
You
that's
have
what
like
I
4 weeks to figure it out.
The injuries. There you go. That would be an easy one because you wouldn't have to do, you would just get an athletic injury history.
Mhm.
That doesn't take any time at all.
Yeah,
And then just do one examination of their mechanics and see if there's, so it really wouldn't be as time consuming.
yeah. No, it was very time consuming
Yeah.
trying to well, once we had the study all planned out, trying to coordinate people's schedules and trying to figure out what time of day we were going to go do the study and yeah.
I think something else to think about would be the time of day that you took the test.
Yes.
Mhm.
So if everyone's practicing at 3 o'clock and you're doing something in the morning, wonder if that would affect their stride frequency and length, and maybe even how much sleep they get the night before. Because I feel
True.
like
Mm-hmm.
biomechanically, like your coordination, nervous system, that all plays a role.
I
Yeah.
also
Interesting.
realize they don't all practice at the same time. They like to make this really challenging.
Yeah.
This group runs in the morning, this group runs in the afternoon.
But
this group
tomorrow,
runs it-
but
and
tomorrow.
tomorrow's different. And
Oh,
That definitely adds.
that's a lot, yeah.
so yes, he had a lot of
A
fun
lot of things to navigate.
arranging things.
Yeah. But we
Welcome to
did.
human research.
Yeah. That's
why I
Dr.
work
Fox
with
has been telling me
rats.
that also.
That's a lot,
Yeah.
And
Rats
I-
are so much easier.
We had some time requirements of since your last training
Yeah.
session, since your last competition. Oh yeah, he had plenty of variables to
Yeah.
work around.
So were you a subject?
I was not.
Were you injured?
No, I like
Okay.
turned in a paper I didn't sign, and then
We just ran out of time.
yeah, we just didn't
Yeah.
get around to it. Kind of busy.
Well done, Dave.
Thank you.
It was a good intro to research.
Yeah, for sure. It's definitely an eye opener, that's for sure.
Yeah,
Yes.
Mhm.
yeah. Rats are so much easier. Yeah, they do, and I've been bitten by them. And then when you go to the student health and get a tetanus shot, and you tell them, I need a tetanus shot because I've been bit by a rat,